Okay, so we've been through the overview of the main types of studies that have been conducted in relation to DIY and open source diabetes, but there are a couple of examples that have more recently been conducted that bring more of a traditional diabetes scientific research approach. So it's a combination of a more traditional science with the open source community. So the first of these studies is known as the JABE Loop Observational Study. The JABE is just a big diabetes research center in the United States, and Loop is one of the two main open source AID systems. This was a prospective observational study of users of the Loop DIY system. So a prospective study means that they enroll people and collect their data after enrollment. A retrospective study means you enroll people in the study and then you look at their existing data or their prior data. And the purpose of this study was to provide evidence around safety and efficacy of the Loop algorithm to be used as the basis for submission of TidePool Loop to the FDA. Now, TidePool is an innovative, not-for-profit diabetes data organization who do everything. All their work is in open source, and they provide data visualization and data management for diabetes clinics. They also provide similar sorts of services to researchers, but individual people, people with diabetes can also use TidePool as well. The second study is the CREATE trial. I'll declare my conflict here. I was one of the investigators on the CREATE trial. This was really the gold standard evidence. So a two-arm randomized control trial of the Android APS system. So we had an intervention arm and a control group. They had access to similar technologies, but only the intervention arm had automation. The others were having to do everything manually. So a large group for a trial, 97 participants from age 7 up to, I think our oldest participant was in their 70s. And that's created a really high level of evidence, the highest you can really get for DIY APS. And so this type of study that the CREATE trial was 6 months long with a 6-month continuation phase. This is the highest quality of evidence that exists for any type of AID system. So only a very few of the largest commercial system studies have been at the scale of the CREATE trial. So let's have a look at each of these. So the Loop observational study was a convenience sample. That means they just enrolled people who were new users of the Loop DIY system. So there was publicity about the study on the Loop website and so on. And then so they enrolled 588 people, which is a great number of people, really big number. And then they excluded some due to some issues with the data. They got information on their time and range before they started looping, and they tracked that through to after they started looping for 6 months. And you can see it increased from 67% to 73%. You might think, oh, 6% isn't really very much, but the thing we have to recognize is that 67% as a baseline is actually really high, and the higher you get up as your baseline, the less scope you actually have for improvement. And the percentage of participants who got at least 70% time in range increased from 44% to 63%. So 70% time in range, that's time between 3.9 and 10.0 millimoles per mole, is sort of the gold standard recommended number to reduce the risk of complications. There's now some debate around whether that 3.9 to 10.0 is the best range to really focus on, but that's what the current consensus is. And the biggest improvement in time in range was seen overnight, where time in range went from 66% to 76%. So a bigger improvement in time in range overnight. That is comparable to commercial studies where basically you take food out of the equation because people stop eating when they go to bed, and the algorithm, the system, finally has a chance to battle its way through whatever else has been going on and get glucose numbers down to a good level. So some really positive findings there. Overall improvements in time and range, and evidence that new users find it useful and successful. But then if we go on to the CREATE trial, now the value of the CREATE trial is this recruited people who weren't using DIY systems at all. So from the normal, if you like, or the typical diabetes community within New Zealand, recruited them in, trained one group on how to use the algorithm, and so they had automated insulin delivery, and the other group just had the CGM and the pump, but no automation to connect the two. We ran that for 6 months. We had baseline data, and then we collected data through the whole trial, but the primary outcome, the comparison, was average time and range in the last fortnight of the study, and the comparison between the two groups. Now what you can see is that in the graph is that the baselines weren't quite identical in the two groups. So the control group had a slightly lower baseline, not radically so, but slightly lower baseline, and then actually the control group went backwards over the 6 months, so they ended up with a lower time and range. And we, so taking into account that they had different starting points, we then measure what were the end points. And so that mean adjusted difference is what we're looking for, of 14 percentage points. And the average there being of time and range and being above that target threshold of 70%. So participants in the intervention arm had on average 3 hours and 21 more minutes time and range every day than the control group, at least where we measured it in the last 2 weeks of the trial. In the continuation phase data, we actually looked at the data across the whole 6-month intervention and 6-month continuation phase, rather than just sort of those blocks of 2 weeks, and we found that that was consistent throughout. There were no serious adverse events in either group. That's things like diabetic ketoacidosis or severe hypoglycemia that requires hospitalization, so that's positive. And these data from the primary outcome from the intervention phase and the control phase, the continuation phase, provide evidence for the safety and efficacy of open source AID, or at the very least the version that we tested, which was Android APS. So this is, as I say, the gold standard evidence. We now know that healthcare professionals don't need to have concerns about someone starting up on these systems, but we also are aware that there are challenges to using these systems where you've got to do more work yourself to get them up and running. Now that we have this data for efficacy and for safety, a number of us who've been doing research in the open source space sort of have a, well, what next sort of question. A lot of open source users are very committed to open source and want to keep going with open source artificial insulin delivery for their own use, but I think there's a broader question around what is the purpose and the role of open source. It's certainly had a role in driving innovation forward. There are a lot of things that have been developed through the open source community that have been picked up and used by particular commercial systems, and that's really positive, because what we want to see are the most effective, the most useful systems being made as widely available as possible. When I was doing the qualitative work with participants from the CREATE trial, I won't present all of that here, what we found is that the participants loved the system. They would have liked to keep using the system from the trial, but they planned to go to a commercial system because what they really valued was having dedicated user support. In the trial, that came through our study nurses, but with the commercial system, there's a phone number you can ring to talk to a technician 24/7 if you have any issues. Whereas in the open source community, you've got the online forums to go to if you need support. So just a few differences there. But really major data, really important data that's come out in the last 12 months. And relatedly, if you remember, I mentioned the JABE study was wanting to be used as a basis of submission of Tide Pool Loop to FDA. And in February of this year, the FDA gave approval to Tide Pool Loop, so it can now be used as part of a regulated automated insulin delivery system, which means that healthcare professionals will now have far fewer concerns about supporting that. The challenge is that the regulated approved version has no pump partnerships, so they can't actually deliver it yet. and they're waiting to form a relationship with a pump partner, insulin pump manufacturer, who will work in with them. They have CGM partners, so they just need to put the insulin pump in alongside that, and they'll be good to go. So some really exciting developments that have come through the open source and user innovation communities.